hopefully we'll see if anybody else joins us, or if we're small group. I like to do tutoring a little bit early. I've had mixed experiences with people showing up, depending on, like, some people, like, if you do it earlier, they don't show up. If you do it later, they show up. I don't know. At this point, I think most of it's going to be on my schedule. If I have the time to do it, I'm just going to do it, and whoever shows up, shows up.
I don't mind that idea one bit.
Okie dokie. Let me pull.
Well, on the bright side, everyone now knows my Linus student number.
Gonna hide that. It's gone. Don't worry. It's just recorded. It's fine.
I'm being a smartass.
I don't think I've ever even noticed that was there when you sent me these.
I never noticed it. It's fine.
In the back of his book, that's the number it assigns you. Essentially, is what it is.
Ah.
Huh.
It's not my actual Parker University student ID number. I would hide that if that was on there.
I'm gonna cry if he leaves after this try and we don't have him next try. I don't know what I'm gonna do.
Dr. Sarkar, or who?
Yes, there's a rumor floating around that he's leaving.
Oh, that's been a rumor like every single try since I was try 1.
Okay, that's good to know, because I'm like, he can't leave yet, because I've just gotten used to how he does things, and just no.
To be honest, if he does leave, there's like a 90% chance that they just like put all of his videos and stuff and use all the same stuff and just have another person do live sessions. Like, it'd probably still be the exact same
material
thing. Yeah. To be completely honest.
I would hope so, because I don't know what I would do.
Okay.
I'm not complaining. His class this term has been a lot more enjoyable. I don't feel as panicked.
There's kind of, it's really hard try 1 when they kind of throw you in there to get adjusted to everything and like start to feel comfortable, like to do everything. Definitely think that it'd be really, really nice to have a little bit more of like an onboarding, what to expect, how to do stuff kind of process, but hey, that's just my opinion.
I wholeheartedly agree with that.
Oh yeah, absolutely. It took me way longer than I feel like it should have to adjust, but I'm sure we all feel like that, so.
Yeah, and then you get through everything, and like, then all of a sudden you're a try 9, almost try 10 like me. And it's like, what the heck? How did this happen? Okay. Let's dive into the fun stuff. The Pentose phosphate pathway. I'm going to be completely honest and very transparent with you guys. This is probably like one of the least understood things in Biochem 1, just because, not that he didn't like go over it super well. I just felt like it was kind of a blip of like, oh, here's the pentose phosphate pathway and moving on. I don't know if you guys have felt the same way. That's how I felt when we did it, and I didn't really understand it until I went back and started doing tutoring and the YouTube stuff and all this other stuff and really kind of spent a good chunk of time going over it. It's been a little bit since I've gone through it, so we'll kind of go back through it together again. But yeah, so
definitely
he does
in the video this week.
Yeah. He definitely likes questions about the pentose phosphate pathway, because the pentose phosphate pathway also comes back up pretty regularly. If I'm not mistaken, it comes back up a handful of times in Biochem 2. So if you don't have a good grasp of it here, some stuff later on gets a little bit more confusing. That's why we're going to slow down and make sure that we kind of go over this. Okay. So we talk about sugars of the different hexoses. Glucose is one of the examples of a hexose, but we also have our other monosaccharides, the fructose, galactose, and mannose. The fructose, many of the different fruits contain sucrose and fructose. Sucrose, we talked about yesterday or Sunday, that it gets broken down into our 2-glucose and fructose, and we need to have different ways to kind of break down these other sugars to metabolize them in order to get the stuff that we need. So we have a couple of different these different pathways, these different processes. So we have like the metabolism of fructose right here, how it all gets broken down. And the goal again is to get everything back into either into glycolysis so that we can use it. So if it's a sugar, we need to be able to use it like a sugar. So a couple different ways, specifically in the muscle. It's really, really easy. We can just use ATP using a hexokinase. We bind a 6 to it. And if you remember, one of the very first steps of glycolysis converts glucose 6-phosphate into fructose 6-phosphate, and then we can just dump it straight into glycolysis. The liver is a little bit different, where we go from fructose, it goes into the liver, it goes through a kinase to become fructose 1-phosphate, and now it can kind of go a couple different ways. So we rearrange the structure a little bit to become fructose 1-phosphate, more like the open chain style. So it breaks it up from its hexokinase structure, the hexagonal structure, into more of an open chain. Then we have our fructose 1-phosphate aldolase, which converts it to glyceraldehyde. And again, kind of glyceraldehyde is one of our intermediates in glycolysis. So we can continue to follow it down. We use another kinase, again, to get our glyceraldehyde 3-phosphate, G3P, if you remember talking about that. And that gets plugged into glycolysis. Or we can go the long way. We use an alcohol dehydrogenase to get glycerol. Glycerol goes to lipid synthesis. This is where you're going to talk about pentose phosphate pathway and like these things breaking down, getting glycerol. Because if you remember, a 3-chain fatty acid, remember what that's called?
Triglyceride.
Triglyceride, right? That glycer part, that is a glycerol, where we have a glycerol. I already have it drawn here. I'll erase this and redraw it. We have our glycerol backbone right there, and then 3 lipid chains coming off of that. So this red right here is our glycerol. So we need the glycerol and we use it to create fatty acids, to create triglycerides. Which is why if you've ever heard of, if somebody's gone to the doctor and you hear them, they say that, oh, you have like fatty liver disease, that kind of stuff. A lot of that's because the excess sugars and the excess stuff in our bodies get processed by the liver and get turned into triglycerides and stored a lot within the liver, or then they go off into the bloodstream and get stored in other parts of the body. But that's one of the reasons why you talk about the liver being fatty. You'll talk a lot more about lipid synthesis in Biochem 2. I think like that's like the whole first chunk. The first week or two, I believe, is lipid synthesis in Biochemistry 2. So you'll get a lot more into that later on. So we can go down that pathway, get glycerol, and we continue with the glycerol kinase to get glycerol 3-phosphate. It goes to dihydroxyacetone phosphate. That it was DH, I think DHP is what we called it. Which, if you remember, kind of in the second split of glycolysis, when our 6 carbon gets split into 2, when it's split into 2, we get the glyceraldehyde 3-phosphate, and then we get the DHP. And the DHP gets converted with an isomerase, just like here, in the glyceraldehyde 3-phosphate to then go into the second part of glycolysis. So this is, again, when you have charts and stuff like this, things that move, just make sure you understand the process. I would take some time, write down the different enzymes, the different steps, where they all go, and just write down the overall general flow of how this all goes. Specifically in the liver, the muscle is pretty simple. You just have a hexokinase, and it gets the phosphate on it and goes right to glycolysis. We talk more about this is kind of all that we just talked about in all of words. Then we have galactose metabolism, which needs 4 different reactions to enter glycolysis. So we get to see all of that, those are reactions. Same thing here, galactose 1-phosphate. If it has a phosphate, it's a kinase, galactokinase. Then it's going to get, we have something called a UDP glucose, which they kind of exchange parts. You get UDP galactose, and then the other side becomes glucose 1-phosphate, and then converted to glucose 6-phosphate and into glycolysis. A lot of this, again, this is just take your time, stop, draw this stuff out, and we'll see a couple of these in questions, and we'll come back and kind of review this and go through each of and look at the important steps. But just want to take a quick look at it now before we jump into questions. Mannose, again, a little simple, because there's a hexokinase and the phosphomannose isomerase to give us fructose 6-phosphate. This is another big one where it's really just recognizing the names and the steps. Pentose phosphate pathway. I'm going to read this little paragraph because I want you guys to understand the importance of this pathway. And then we'll quickly go through this a little bit, and then we'll go to the questions. So big idea for pentose phosphate pathway is it is how we are going to get build the base blocks for building of DNA. Okay, we are ribose or ribulose. We need it for DNA because it's a deoxyribose. So we're going to be using that. So our nucleic acids, as well as the pentose phosphate pathway, is a way that we can kind of recycle everything and bring it back to the top to be able to continue to produce energy in different conditions. So the pentose phosphate pathway, it is an alternative pathway to metabolize glucose. It is accomplished by an alternative pathway to metabolize glucose is accomplished by the pentose phosphate pathway. And you'll see them refer to it as pentose phosphate pathway or PPP. Just remember that PPP stands for the pentose phosphate pathway. So the PPP does not oxidize glucose via glucose 6-phosphate to produce ATP. Instead, this pathway produces specialized products such as NADPH. We want to look out for NADPH. Anytime we're talking about pentose phosphate pathway, that's always a good answer choice to look for. Even if we don't necessarily understand the question, we look for the keywords. So NADPH required for numerous reductive biosynthetic pathways and provide pentoses, those 5 unit sugars, for nucleic acid biosynthesis. Our nucleic acids are our DNA and our RNA, which code for everything that happens in our bodies, including production of other monosaccharides such as ribulose, xylulose, erythrose, fructose, acetoheptulose, glyceraldehyde, etc. All those names, don't worry about all the names, they're not super important. And it's required for the synthesis of other important biomechanical molecules in humans. So besides ATP, cells also need reducing power of NADPH for biosynthesis. We get their anabolism. NADH is going to be used for the oxidative metabolism or catabolism. And we have the nice ratio. Okay. Now the actual pentose phosphate pathway, what we talked about earlier, the pentoses, it's specifically ribose 5-phosphate is required for the nucleic acid biosynthesis. So we have a couple different parts. think there's just the two parts that yeah. There's the oxidative reaction. I don't remember what the name of the second part is, but this is a lot of times something that he asks about is specifically like what type of reaction the first part is. It's oxidative, where the glucose 6-phosphate is going to be oxidized to, again, we want to read out all of these names because if you can read the name, you're more likely to remember it. Glucose 6-phosphate is oxidized to 6-phosphoglucono delta lactone by glucose 6-phosphate dehydrogenase. And then we get a molecule of NADPH. You should have this drawn out, yeah. So glucose 6-phosphate gets acted on, we get 6-phosphogluconate. Then from there, we get the next step, which it gets converted by the 6-phosphate gluconolactone hydrolase. It feels like I'm reading a lot of names, but when we get to the questions, we'll break it a little bit more down. Oxidative decarboxylation. So remember decarboxylation, we're breaking off a carboxyl group. That happens by NADP. We get that ribulose 5-phosphate carbon dioxide and our second NADPH. Okay. And those last couple of steps, we'll see more of those when we talk about the questions. Okay. A little bit confusing right now, I'm sure, just because there's a lot of weird, funky names in here. But as we go through the questions, it'll hopefully become a little bit more clear. Again, as always, if we have any concerns, questions, things that are confusing, stop me as we go through the questions and we can go over them, make sure that we understand exactly what's being said and kind of what's going on. Okay. Question number 1. The pentose phosphate pathway is a reductive pathway, an oxidative pathway to metabolize glucose and or glucose 6-phosphate, an oxidative pathway to metabolize pyruvate, or a process that synthesizes glucose.
Well, it's
Oxidative.
oxidative.
So we know for sure it's an oxidative pathway. So immediately we can get off a reductive, and it also does not synthesize glucose.
And it doesn't have anything to do with pyruvate, which makes it metabolize glucose and or glucose 6-phosphate.
Exactly. So right there, bam. Good process of elimination. It's a perfect way to attack this question. So it's an oxidative pathway to metabolize glucose and or glucose 6-phosphate. Next question. D-galactose is a product of hydrolysis of lactose. Which of the following hydroxyl groups or groups of D-galactose is/are phosphorylated by galactokinase? This is a question that I think even in the book, I don't think it ever actually like talks about it in the book. So this is one of the questions where I would say I would start this question, be one to come back to and look at right before the test. Because this kind of thing is going to be one of the questions that he's going to throw on the test just to kind of confuse people a little bit. Let me see if by chance I can find. I'm pretty sure I looked through this a little bit before we started, and I'm fairly certain doesn't mention this specifically in the book. I don't see it. Okay. Couple things that we do recognize here, though. Hydrolysis of lactose, right? Lactose is a sugar. Who can tell me what lactose is made of? Lactose is a disaccharide, which means it's made up of 2 monosaccharides. Who can tell me what the 2 monosaccharides of lactose are?
Glucose and galactose.
Very good. So we have glucose and galactose. So specifically we're saying that galactose is part of lactose. So now we want to look and focus on galactokinase. Where is the galactokinase located? I think we briefly mentioned it when we were looking at the book. Let's find. Here we go. Our galactokinase. Whenever we have galactose, the galactose is going to get turned into galactose 1-phosphate by our galactokinase. And then we have the whole process coming back to UDP. And so we'll get there. We'll get a little bit more into that when we talk about it specifically. But we can look at this here. Galactokinase turns it into galactose 1-phosphate. So specifically when galactokinase acts on galactose. Oh, where'd my... moving things around on accident. Specifically, galactokinase is going to link on the first carbon only, because we see with the metabolism of galactose, it goes from galactokinase acts on it, and we get galactose 1-phosphate. It's just the first carbon. It links to the first carbon. Again, I really hate these questions because they don't feel like they actually test like their understanding. It's more just kind of raw memorization type stuff. Okay. Formation of NADPH is a blank kind of process. Is it a transamination process, oxidative decarboxylation, reductive, or oxidative?
Oxidative? Reductive.
I was gonna say reductive, yeah.
So it is a reductive process. Can anybody explain kind of why it's a reductive process?
Because in reductive processes, you're going to gain hydrogens or electrons or lose oxygen.
Yeah, so if we go back to our... I'm going to put the book there. Looking at our pentose phosphate pathway, right? We're transforming, if we're going from NADP plus, adding on a hydrogen and electrons to get NADPH. So we are reducing, because we have oil rig. Reduction is gain of electrons. So we're gaining electrons onto this. So we are reducing our NADP plus to form NADPH, which means that this is a reductive process. If we were to change the question and say, in the formation of NADPH, which of the following happens to our glucose 6-phosphate? Is our glucose 6-phosphate being reduced or is it being oxidized?
It's being oxidized.
Yeah, the glucose 6-phosphate, because it is giving up the hydrogen to the NADP plus, this is being oxidized and this is being reduced. So you can ask the question either way. Still, it's asking the same general concept. Just make sure that we read the question carefully and understand kind of what is being reduced, what's being oxidized. Oh, no, do not close. Okay, fructose is converted to which of the following compounds in the liver tissue, so liver tissue specifically, immediately before it enters the glycolytic pathway? Glyceraldehyde 3-phosphate, fructose 1,6-bisphosphate, glucose 6-phosphate, or fructose 6-phosphate?
Fructose 6-phosphate?
G3P.
Yeah, it's one of those two.
Let's go back and look. Sorry, it was fructose. Fructose. So we go too close. From fructose, we're talking about the liver, right? Liver has a bunch of our steps. We go to fructose 1-phosphate, then we get it open chain. We can go to glyceraldehyde, or we can do the other opposite loop. But either way, we're both going to end up into G3P, or glyceraldehyde 3-phosphate. What is the name of the first enzyme as fructose enters into the liver? What's the very first enzyme that acts on the process?
Fructose 1,6.
It's what first thing that it becomes. What's the name of the enzyme? I'll give you a hint. It's a kinase.
I was gonna say it's gonna be a kinase, right?
Yep.
Phosphofructo.
Not phosphofructo, but it's going to be just regular
Just
fructokinase.
Fructokinase.
Fructokinase. Good. Our answer here are glyceraldehyde 3-phosphate. If instead of being converted all the way to glyceraldehyde 3-phosphate, instead it gets converted to glycerol, what other pathway can fructose follow? If it gets converted to glycerol, what else can it be used for in the liver?
To make triglycerides.
Yeah, to make lipids, to make triglycerides. Perfect. Fructose is converted to which of the following compounds in muscle tissue before it enters the glycolytic pathway?
This one's fructose 6-phosphate.
Yeah, this one is the fructose 6-phosphate.
I
Remember,
had them
because
backwards.
Yeah. What's the enzyme that allows it that converts it from fructose to fructose 6-phosphate?
Hexokinase.
Good. Thinking back a little bit on our brains. In the muscle tissue, right? In all the tissues, we have hexokinase. What other kinase enzyme do we have that's located in the liver that's not present in the muscle tissues that does the same job?
Glucokinase.
Yeah, very good. Our glucokinase. Just want to remind you of that. That's probably that might be something that pops up on the final in week 15. Fructose metabolites in the liver tissue is/are which of the following? Either all of them, glyceraldehyde, fructose 1-phosphate, or dihydroxyacetone phosphate.
All of the
Oh. I'll say it's got to be all of these because I know glyceraldehyde for sure and fructose 1-phosphate for sure. So it's got to be all of them.
Sweet. So which of the following is the first in chronological order? Which of them comes first?
Fructose 1-phosphate?
Yeah, fructose 1-phosphate. And what's the name of the enzyme that converts fructose to fructose 1-phosphate?
Fructokinase?
Yep. Fructokinase. After it gets converted to fructose 1-phosphate, what is the second? We call it it can be called the second step, but it's kind of like it's not like an actual step. It's just something that happens to the fructose 1-phosphate. What changes about the fructose 1-phosphate?
It loses its ring shape.
Yeah, it becomes an open chain, right? Becomes open chain. And then from open chain, what happens next? As much as you can, I know if you guys do have like your book and other things open, that's fine. Try your best right now to force your brain to think and remember these things. The more that we struggle a little bit, the more your brain is going to develop those channels, especially once we hear the answer and we keep beating it into you. Anybody think
Is that
what it gets
where it
converted to?
can? Is that where it can do the glycerol? Is that
Almost.
that
There's
thing?
one more step. There's one more step. So from once it becomes open chain, it gets converted to glyceraldehyde. This is by a really, really long enzyme. We're going to shorten it. It's F1P because it's our fructose 1-phosphate. Aldolase is the enzyme we convert the open chain fructose 1-phosphate into a glyceraldehyde. Can anybody give me a rough definition of aldolase?
So it works on 5 carbon sugars. Because, I'm sorry. Oh, aldehydes. It works on aldehydes.
Yep.
Sorry.
There we go. So we have the aldolase works on the aldehydes. So if you can work through, remember, keep as much as you can, break down words and remember those kind of things. That's what we want to remember. Because later on, every now and then you're gonna see names and words and stuff that you look at them, you're like, I have no clue what that means. But if we break it down a little bit, it's gonna help us to kind of understand what their role is, even if we don't necessarily remember it entirely. Okay, now I'll pull up from here, our glyceraldehyde at our glyceraldehyde. This is where we can kind of break off into two different paths. Sorry, give me one quick sec. Okay. When the wife texts you to do something, you do it right away. Okay. So at glyceraldehyde, this is where we can kind of break away and determine which way we're going to go. A way to remember this is if we remember that the last step is glyceraldehyde 3-phosphate, because that's what's going into glycolysis, being inserted into glycolysis. One step before that is going to be glyceraldehyde. So it can split here into that glycerol and then make a whole big loop, or it can just go directly to the glyceraldehyde 3-phosphate. Okay, next question. Super long question. Whenever we have a super long question, what do we do? What's the first step that we should do?
Read the last sentence.
So right now, choose your best answer from the following. That doesn't help us a lot. If your answer is no, yes, this has a lot of complex stuff. Okay, so then we're going to just go right back to the beginning. Glucose is an aldohexose sugar. So it's 6 carbon sugar. It's an aldehyde. Cool story. Can glucose be converted to a ketopentose sugar? So now we have aldehydes, right, to ketones, and a hexose to a pentose. So can we go 6 to 5 and an aldehyde to a ketone? If your answer is yes, identify the ketopentose sugar. If your answer is no, identify the compound which is derived from glucose metabolism, but not a ketopentose sugar. Choose your best answer from the following.
Would it be B?
I think it's A.
I was gonna say I
A?
think it's A
Okay.
because with the no answer having the ribulose in it also, that makes me think, well, that's not the keto pentose sugar because that's usually how he does things. And
Oh, and
so
isn't
that just
ribose an aldehyde? It might be an aldehyde anyways. So that doesn't make sense. The ribose.
I think
Okay.
Yeah, so ribose. This question is kind of combining of a couple of chapters ago of like the naming of the carbohydrates. So ribose is an aldehyde. Ribulose is a ketone. And it's a ketopentose, but then if it did get converted to that, that was supposed to be a yes. And so because this right here, we automatically know that because ribose is not a ketopentose, that can't be true. So then our last choice is a xylulose 5-phosphate, and it is a ketopentose sugar. And I want to see I don't remember seeing this specific reaction in the book. Let's see if we can find it. Glucose. This whole chapter is talking about is things other than glucose, though, so it might be under the pentose phosphate pathway. That part where we right here. So glucose. Production of other monosaccharides such as ribulose, xylulose, erythrose, fructose, and this guy. So it's technically in the book. I would say it's kind of a stretch though. If he does put a question like that on the test, he's probably going to put like this exact question on the test. Because if he tries to put one similar to it, there's not really a lot of resources to draw from there. So if he's going to put a question like this, you're going to see almost this exact same question. Any questions about how we got to that answer? Okay, moving on. Hydrolysis of sucrose produces which two monosaccharides?
glucose and fructose.
Glucose and fructose and glucose. What does lactose produce?
The lactose and glucose.
There we go. What about what was the name of the other most common one?
I'm sorry, so how do we know the answer?
This one is pure memorization. We want to remember, so these ones, and these are super, super important. So sucrose equals a fructose and a glucose together. Lactose equals glucose and a galactose. There's another.
Hey, Kat, he talked about that with us on yesterday morning.
And then maltose is another one that's often. And maltose is glucose plus glucose. You will see these three on exams in biochemistry 1, potentially biochemistry 2, in physiology, in clinical nutrition, on boards. They always ask one of these on boards. So I always had a really hard time memorizing these, but just again, practice these a handful of times, get used to seeing these. You might have to review them a couple of times over the next couple of years as you take courses. But these he always has at least one or two questions just like this, either on y'all's next exam or your final exam. He'll have at least one or two of these. Just because it's one of those things where it's super, super simple, but it's very much either you know it or you don't. So these three, sucrose, lactose, and maltose, those are the main three that you will see over and over and over again.
I always talk myself out of maltose being two glucoses, and so I don't remember it because I talked myself out of it.
Yeah. Okay. In one reaction, in galactose metabolism, we're talking about galactose metabolism, galactose 1-phosphate is converted to glucose 1-phosphate. Which of the following compounds are used in the metabolic pathway to produce glucose 1-phosphate? This one we skipped over a little bit, so we're going to come back to it. We had that first step. Galactose acts on the number 1 to get galactose 1-phosphate. And we have this beautiful metabolite called UDP glucose. Don't ask me what UDP stands for. I don't remember. At one point I did. And I have a feeling that we should look that up.
Uridine
Because-
diphosphate.
Yeah, you're right. Uridine diphosphate. He's going to write it like that at some point on some exam question. You're going to need to recognize it. The deep part of my brain is itching like that's important. So I would try to listen to that part of my brain. So converting galactose 1-phosphate into glucose 1-phosphate, we use a UDP glucose and to convert it, and we then get the glucose 1-phosphate and a UDP galactose. So which of the following compounds is used in the metabolic pathway to produce glucose 1-phosphate?
UDP glucose.
Our UDP glucose. How could we change this question to make UDP galactose the correct answer?
The next step. So from the glucose 1-phosphate to holy crap, just forgot what it converted it to. Wow. My brain stopped working mid-sentence.
It's good. Look at it and complete your thought.
Where did that go? I'm struggling, apparently.
It's all good. Sometimes that happens.
Gracious.
Super easy way. So when we look at this, which of the following compounds are used in the metabolic pathway to produce glucose 1-phosphate instead of used in the metabolic pathway? Which of the following compounds result from? Replace that with result from the metabolic pathway to produce glucose 1-phosphate. Just by changing that one little word, this is now our answer, UDP galactose. If it's a result from, just so when you read the questions, read them carefully, especially, this is a good life lesson for everybody going through the program. Some teachers will reuse very similar questions to quiz questions. But I'm specifically talking about Try4. Dr. Perryman is infamous for this.
Yes, I took him in A&P and he did it.
He'll take previous quiz questions or like previous test questions that he's used in trimesters before, because there are previous tests either on Quizlets or other things floating around out there. So and they're, if you find them and you use them to study, they can be a great resource. However, if you try to just memorize random questions and then go off of that, a lot of times they'll change one word or two words out of the whole question, and that changes the whole meaning of it. So just make sure you read the question carefully and understand what the question is asking.
Dr. Perriman is wonderful, but he definitely does do that. And he told us when I took him for A&P, he was like, he told us he did that. He was like, I know my questions are out there, so I changed them just a little bit, so you have to pay attention.
By far, Dr. Perryman is probably one of the top 10 professors I've ever had. Probably top five professors I've ever had through my entire academic career. I loved his classes. He is one of the most knowledgeable, one of the most caring individuals as far as like wanting us to learn stuff, and how much he knows, just how much he knows in his brain is baffling. It is amazing. Fantastic teacher. Okay. Oh, in the non-oxidative stage of the pentose phosphate pathway, intermediates of blank are produced. We didn't quite go over this when we were looking at the pentose phosphate pathway, so we can go back.
Before you get there, though, would it be glycolysis? Because that's kind of where everything's going.
The answer, yes, the answer is glycolysis. I want to find the good. This is a lot on the oxidative reaction. It doesn't have a great picture. Of the non-oxidative phase. Probably, I should have one in my notes somewhere. It's gonna take too long to look up. It's fine. The answer is glycolysis in this case. It's glycolysis. I'll see if I can find a better example of the pentose phosphate pathway, because I remember that's one of the reasons why it was a little bit confusing in his when I was reading through his book and stuff, is because he didn't have like a super cohesive pentose phosphate pathway. So I'm gonna look for one and see if I can find a better example that's a little bit cleaner. I think I have one in my notes somewhere, but if I could find that, I'll send that out to everybody. Okay, which of the following is true about the pentose phosphate pathway? So it's either all of the above, it produces FADH2, it synthesizes nucleic acids, or it produces aldopentoses.
Well, for sure synthesizes nucleic acids, right? Am I making stuff up? I think that's right.
Aldopentoses.
So read the paragraph real quick. Elizabeth, just read. Can you read out loud for me this part right here?
Required for numerous reductive biosynthetic pathways and provide pentose for nucleic acid biosynthesis.
Yeah, so the pentose phosphate pathway is not responsible for producing the nucleic acids. It's going to provide the pentoses, which then make the nucleic acids.
Gotcha.
Really, really important distinction that I wanted to make there.
Gotcha.
So it's going to produce the aldopentoses. That these are then going to go through another process to help produce those nucleic acids. Because you think when we get, you guys have talked about, you all talk about DNA synthesis in BCT?
Probably, but I don't remember currently.
Like G goes to
I think
C, A
probably
goes to T. You have the different, you have
Yeah.
the different components. Yeah, so the G and C and the T and the A, all of these individual components, and then what they eventually attach to, they attach to sugar structures. Each of these is attached to a sugar structure, and then the sugar structures bind together like that. These sugar structures that they're attached to, those are the pentoses that are produced in the pentose phosphate pathway. That then they all bind together to form and to create the helix structure. So the job of the pentose phosphate pathway, we get those aldopentoses, which then are taken off and then can be used to produce those nucleic acids. What reaction is catalyzed by galactose 1-phosphate uridyl transferase? Formation of UDP glucose, conversion of galactose 1-phosphate to glucose 1-phosphate, formation of glucose, or conversion of galactose to galactose 1-phosphate.
Catalyst.
So specifically, we're looking here. If we remember, if we think about galactose, we didn't spend a ton of time looking at the pathway. But let's so here, so we start with our galactose, right? And it gets acted on by an enzyme. What's the name of the enzyme that acts on the galactose? It turns it into galactose 1-phosphate. So that should be a clue.
Would that be galactokinase?
Yep, galactokinase. And then our galactose 1-phosphate gets converted to glucose 1-phosphate by this lovely enzyme, our galactose 1-phosphate uridyl transferase. Uridyl transferase. That's our enzyme right there. So they kind of just gave the answer away, right?
Oh, yeah, so conversion of galactose 1-phosphate to glucose 1-phosphate.
Perfect. Yep. What is used along with this enzyme? What else is one of the reactants that helps in this process? All right, so we have galactose 1-phosphate to our glucose 1-phosphate. This is our galactose 1-phosphate uridyl transferase that acts there. What are other two-part components here and here?
UDP glucose and UDP galactose.
Correct. UDP glucose and UDP galactose. Good job. Which enzyme converts UDP galactose to UDP glucose? Well, we look at each of these. We should be able to recognize most of these, right? Galactokinase. What's galactokinase's job?
To go from galactose to galactose 1-phosphate.
Perfect. So that's not it. What is our UDP glucose galactose 1-phosphate uridyl transferase?
That's the galactose 1-phosphate to glucose 1-phosphate.
Perfect. So that's not it. are phosphoglucomutase. If I'm pretty sure, I don't even remember seeing that as a whole thing at all. Actually, that's the next step. Phosphoglucomutase is our last step to go from glucose 1-phosphate to glucose 6-phosphate to shoot it into glycolysis. So this one is glucose 1-phosphate to glucose 6-phosphate, which leaves us with which enzyme?
UDP galactose 4 epimerase.
Yeah. So in your own words, what's the job of UDP galactose 4 epimerase? Why is it important? What happens if that enzyme isn't working? We cut out this enzyme right here.
So that whole process stops and you can't end up with your glucose 1-phosphate or your UDP galactose there.
Yeah, right. So we cut off our supply of UDP galactose. If this enzyme doesn't work, because we need it to convert UDP galactose back to UDP glucose, right? So because if we don't have UDP glucose, we can't continue the process of converting the galactose 1-phosphate into glucose 1-phosphate. So essentially, without this enzyme here, if that enzyme's gone, this whole process, we get stuck and then we can't metabolize galactose. That's the importance of this enzyme right here. Okay, which is the immediate precursor molecule in the pentose phosphate pathway that generates ribose 5-phosphate. So a couple keywords. Immediate precursor molecule. In simpler words, what does that mean?
Immediately before it happens.
So we're looking for the part of the set. We're looking for something that then gets converted to ribose 5-phosphate.
Ribulose.
Honestly, looking at this right here, because what's the difference between glyceraldehyde 3-phosphate and glucose? Or let's look at ribose 5-phosphate is has how many sugars in it? How many sugars does ribose have?
2. No, that's not right.
Right, it's an aldopentose, right?
Pentose, yeah.
How many sugars does it have?
5.
5.
It's got 5. Glyceraldehyde 3-phosphate. How many carbons does glyceraldehyde have? We got to think back to glycolysis.
Not sure.
So we think about the steps of glycolysis, right? Glyceraldehyde 3-phosphate is formed when we get the splitting. We get glyceraldehyde 3-phosphate and DHP, right?
Mm-hmm.
Up here, we still have like the fructose, everything going on up here. We have a 6-carbon structure. It gets broken down into 2 3-carbon structures. So now glyceraldehyde 3-phosphate has 3 carbons. DHP has 3, and then this does its whole thing and then turns into another glyceraldehyde 3-phosphate, right?
Mm-hmm.
So glyceraldehyde, this has 3 carbons. Glucose has how many carbons?
6.
6. So that leaves us with ribulose 5-phosphate is going to be our answer. That's like kind of the workaround of the whole thing. If we look at the book of the actual process, hopefully this would probably be a little bit easier, seeing from ribulose to ribose. But if you didn't know that answer, know the full pathway off the top of your head, it's another way you can kind of work through it, then think and remember how kind of what correlates and what is similar to each other. Which of the following compounds can generate intermediates of the glycolytic pathway?
Yeah, all of them.
Oop, circle the wrong thing. Circle the wrong thing. I've done that. I've done that so many times where just like even on tests where like I'm like, oh, it's this answer, and then I click the wrong answer and I move on. I'm like, I look back and it's just like, why did I do that?
Can't be any worse than me and my pinky on my exams because I always keep my pinky on my down arrow.
You got to be careful with that. Which of the
Especially on my
following?
laptop.
Yeah. Which of the following compounds derived from the pentose phosphate pathway? So immediately we see derived from the pentose phosphate pathway. So it's going to be one of the end products of pentose phosphate pathway. Is one of the precursors used directly for the biosynthesis of nucleic acids such as DNAs and RNAs.
Ribose phosphate.
The only one that makes sense there is
The
ribose.
ribose phosphate, because we mentioned that a couple of times. It's that ribose. Sweet. And what is the intermediate directly before ribose 5-phosphate?
Ribulose.
Good. Which of the following compounds is/are products of fructose metabolism in the liver tissue? Ooh, this one's fun.
Yeah.
Okay, so we start off, we have fructose, right? And it goes into the liver. What does it turn into?
No. Shit.
I'll give you a hint. We have fructokinase.
Then you end up with fructose
6-phosphate.
6-phosphate. No, 1-phosphate, not 6, 1.
Just one, and then fructose 1,6-phosphate.
Yeah, it's fructose 1-phosphate. Fructose 1-phosphate, then, it gets all opened up. So it gets open chain fructose 1-phosphate. From there is an enzyme. It's an aldolase, right? Specifically fructose 1-phosphate aldolase. What does it become then? What's our next step?
G3P.
Before G3P, because we need to stop at the train station where we can split up. G3P is going to be our last step. We need to split up before that. What comes before G3P?
Glyceraldehyde.
Yeah, glyceraldehyde.
Yeah, our glyceraldehyde.
Which gives us our answer.
Yes.
Well, we're not done yet, right? Because from glyceraldehyde, we can then go and we can continue into our intermediate that's going to go into glycolysis. And what's that one?
That's the G3P.
Our G3P, right? What's the difference between glyceraldehyde and glyceraldehyde 3-phosphate? What's different about those two? I should say, what is different between those two? What changed from glyceraldehyde to glyceraldehyde 3-phosphate?
Phosphate group.
Yeah,
Phosphate group. So the enzyme that did that, what do we think that enzyme is going to be called?
It's going to be a kinase.
It's going to be a kinase. And what does it act on?
If it's glycerol?
Literally, this would acts on glyceraldehyde. So it's glyceraldehyde kinase. That's the name of that's our enzyme. Glyceraldehyde gets acted on by glyceraldehyde kinase because the kinase adds a phosphate and it gives us the glyceraldehyde 3-phosphate. Most of the time with enzymes, they're going to be named after the thing that they act on most of the time. So it's just kind of, watching for that. And whenever it doesn't follow that rule, then that's what you can look at. On the other side of glyceraldehyde, right? Glyceraldehyde can also go and get converted into what?
Glycerol?
It goes to glycerol. That's it is an alcohol dehydrogenase, which involves NADH, where it takes the hydrogen and adds it in there. So we're dealing with alcohols. Now glycerol, right? Glycerol has two choices. It can continue to go and to change into other stuff, or it can go make stuff. What does it make?
Lipids.
Yeah. Good job. From glycerol, then we go and we become glycerol 3-phosphate. Phosphate. What do you think the name of the enzyme is that turns glycerol into glycerol 3-phosphate?
Glycerol kinase?
Yep. Glycerol kinase. Very complicated stuff right now, right? Glycerol 3-phosphate then gets changed again to become DHP. You may remember the name. What's the name of DHP? The actual long name.
Dihydroxy phosphate.
It's dihydroxy something phosphate.
Phosphatase. Or phosphamutase.
What is it?
Hydroxyacetone phosphate.
There we go. Good job.
We're staring right at it.
Yeah, I'm like
The-
not
the-
even looking at my question.
The enzyme that does that is we're gonna have a glycerol phosphate dehydrogenase. What does a dehydrogenase do?
Break something down. I know that.
Honestly, that's literally what I was about to ask because I can't remember.
That's right. D means what?
Lack of.
Lack of, taken away, removal of, right? Hydrogen just means hydrogen, right? So we're dehydrogening. ACE is an enzyme. So glycerol phosphate dehydrogenase removes what from a glycerol phosphate?
Hydrogens.
It removes a hydrogen, right? So if we stop and we think about this, right? Dehydrogenases, what extra thing is it usually going to need, or is it going to use right here to help pick up that hydrogen?
Isn't it going to be like NAD plus, like something like that?
Exactly. We're going to have an NAD plus. I doubt that he'd ask a specific question like where would you use an NADH, but he could ask a question something along the lines of, in the reaction of glycerol 3-phosphate to dihydroxyacetone phosphate, which of the following is used? And he could have either like the enzyme, or he could have the NAD plus, either of those being a perfectly good answer choice. Okay, so now from DHP, finally, DHP goes back to our glyceraldehyde 3-phosphate, an enzyme going to be used called a triose phosphate isomerase. What does an isomerase do?
Isomerase is just rearrange, right?
Exactly. So a chemical structure, all that kind of stuff is the same, but it rearranges it. So the triose phosphate isomerase is going to rearrange our DHP so that it goes and turns into a glyceraldehyde 3-phosphate. And actually, if you think back, these steps are actually very, very similar Like at least like this enzyme, this is the same exact enzyme that is used in glycolysis when we have DHP to convert it to glyceraldehyde 3-phosphate. So a lot of this stuff can come back in the context of glycolysis, depending on how you get asked the question. Okay? Now, finally, answering this whole question, which of the following compounds is/are products of fructose metabolism in liver tissue?
Would it not be all of them?
It is. It is. Yeah, that's right. It is all of it. We have glyceride, we have DHP, we have glyceride 3-phosphate. What if we change the question? Instead of liver, it's muscle tissue. What would the answer be? Okay, it's none of these are the answer. What would the answer be if it was asking what's the product in muscle tissue?
Fructose 3-phosphate?
Fructose 6-phosphate.
6.
Good. Fructose 6-phosphate. Fructose 6-phosphate. What's the enzyme in the muscle tissue that's going to phosphorylate the fructose?
Fructokinase? No. Yes. I don't know.
This one's weird. So this
Or
is
is
where we
that
want to draw attention.
it's hexokinase, right?
Exactly, it's hexokinase. So that's what we want to remember. Sometimes when they are a little bit weird, those are the ones we want to really remember. Hexokinase, because if it's weird, that could be another perfect question that you could ask. Which of the following enzymes is used to phosphorylate fructose in the muscle tissue to enter glycolysis? Something along those lines. And the answer choices, among the answer choices he'd give you fructokinase and hexokinase. And that's when we really want to remember that in the muscle tissue, it's hexokinase and not fructokinase. Fructokinase is in the liver tissue. Hexokinase is in the muscle tissue.
Hey, Drake, question, actually.
Yeah.
Is that a great example of, like, if you read a question up above, like, say question 5 on this one, and you got 17, you're like, oh, it's that? Would that be a good way to relate?
Yeah. Yeah. And honestly, so really, really interesting thing is if you can do this as you take, especially in biochemistry and in future tests, watch out for especially teachers that like to make their questions wordy. A lot of times they'll include details that might help you on future or previous questions. So especially questions like this, where if you think like questions are related, like I love to have a piece of scratch paper. If you're taking a test and they have like doing like the Proctorio camera thing, whatever, show your blank piece of scratch paper. But I like to write down sometimes, like if there's a question that I'm like, that question I need like to go back to, and you don't have like an easy way to flag it, I'll write the number down. And then as I'm going through the questions, like I'll look and I'll see, and sometimes you'll find information in like other questions that tie you back to questions that you've already passed, and that can help you answer those. Okay. Which of the following enzymes catalyzes a reaction in the pentose phosphate pathway? We are going to do so out of everything that we've talked about right now, right? Hexokinase, where do we see hexokinase?
In the muscle with
In
the
the muscle
fructose.
tissue. Yeah. That's not doing that. Phosphofructokinase. 1. PFK, right? What reaction do we see that in?
Glycolysis.
It's in glycolysis. It's not in any of the stuff that we have going on right now. So we're stuck between two. glycogen phosphorylase, and 6-phosphogluconate dehydrogenase. We'll come back and we'll look at our pentose phosphate pathway. This picture is okay. We'll go with this picture. Glucose 6-phosphate, glucose 6-phosphate dehydrogenase, lactonase, glucose 6-phosphoglucono delta, lactone. I forgot which one we're looking at. 6-phosphogluconate dehydrogenase. Let me double check that, make sure. Yeah. This is what I'm saying. Like, I don't love some of these because it's a little bit confusing, but you look right here, our glucose 6-phosphogluconate dehydrogenase. I really like. I wish that I had done these Linus questions when I was taking the class, because it would made this class so much more straightforward as far as studying goes.
So I just noticed something on these questions, and now I'm confused. So on the one before this, on 17, we decided it was all of them. But the answer says that it's glyceraldehyde. Why?
Yep. It's Dr. Sarkar, that's why. Junior, stop it.
Yeah. Most of the time, everything is correct. Yeah, I didn't even notice that. That's weird.
I try to like erase the answers as after we answer them, and I just did that one, and yeah, noticed it.
Yeah, because we have glyceraldehyde right there. Glyceraldehyde 3-phosphate right there. And then dihydroxyacetone phosphate. That's wrong. I'll be straight up.
Okay. Okay.
And it's
Just
okay.
making sure he was wrong and we didn't miss something.
Unless, like, the only reason I could see of that being is that if he has some different definition of like what he's referring to as products, but we did the whole process, the whole pathway.
Yeah.
All of these are products of it. So I would bet my bottom dollar that it's all of the above. So
I'll ask him about it in tutoring this week.
yeah, I'd ask him
like,
about it.
That's one on the test that if you put it on there, I would answer all of the above and then ask him about it after and see if I could get my points back.
Yeah. Because honestly, that's one that's like, yeah, I would 100%. I would ask him about that. Let me know when you find out. If he gives a different definition as to specific why, we'll come back and we'll talk that. But I'm fairly certain that's just a case of the answer got keyed in incorrectly. That's my guess.
Because when I make the Quizlet, I'm probably going to put all of the above as the correct one.
Yeah, I would. That's what I would do. If Dr. Sarkar says something otherwise, make sure figure out his reasoning why and let me know. But yeah, I'm fairly confident that that was just a typo. Which, hey, one out of every however many questions we did on Sunday night,
Yeah.
plus all of
Right.
this, that's we're doing it's pretty good ratios. So okay. Which of the following enzymes catalyzes a reaction in which NADPH is produced? So when we're talking about NADPH, right? What pathway or what process are we talking about?
Is it the PPP?
Yeah, our PPP. So we have 2 instances of NADPH being made. Our first one, I'm just going to show the thing. Our first one is in our first step, our glucose 6-phosphate dehydrogenase. And then again in our glucose 6-phosphogluconate dehydrogenase. And actually, let me take a second real quick. This is going to be secondary soapbox kind of thing. That's not related clinically, like, or related, like correlated to like your tests and stuff. This is like good clinical life stuff, patients / your own health. Magnesium is is utilized in tons and tons of pathways within our body, within our brain, with everything we can see here. So this whole process is how we produce our DNA, right? Production of our DNA, our INA, the expression of genes and proteins and all that kind of stuff is based on essentially based on having magnesium to be able to replicate and do all these things properly. A majority of people do not have sufficient magnesium. Now, this is not doctoral advice in any way. This is something that I personally do and that I personally like. Just to clarify that. Magnesium supplementation, or also going out of your way and making kind of adding dietary kind of things in to increase your intake in magnesium, has phenomenal effects on things such as anxiety disorders, depression disorders, like issues with ADHD, fatigue, all that sort of stuff. That's what I personally use it for that with my family. So if you at some point are dealing with stuff like that, I would encourage you to look up magnesium supplementation, and kind of what that sort of looks like and what the potential benefits are if that's something that you're interested in. Okay.
I would second that for sure.
Hopping off
Because
my little clinical soapbox now.
I've noticed that in personally as well. 'Cause when I remember to consistently take my magnesium, I'd feel so much better than when I don't. So yeah.
And also pairing magnesium doesn't absorb nearly as well unless you have sufficient vitamin D. So pairing, most of the time, a lot of times the supplements will come in like a magnesium vitamin D3 tablet or whatever. But if you're just supplementing pure magnesium, I always make sure to supplement a vitamin D along with it. Especially in times like during winter when it gets cold, you're not outside as much, or if you're a grad student and literally live indoors because you're constantly studying, and don't get outside in order to create more D3, or vitamin D in general. That's, kind of a good thing to keep in mind. Okay, off the soapbox. What were we talking about? Where NADH is produced. Okay, our glucose 6-phosphate dehydrogenase, so step 1, and then our glucose 6-phosphogluconate dehydrogenase. Notice that both of these are NADHP productions happen within the oxidative phase of the pentose phosphate pathway. So answer for this one is going to be our 6-phosphogluconate dehydrogenase. But another acceptable answer to this question could be glucose 6-phosphogluconate dehydrogenase. Another good key thing to look at when we produce NADPH, right? What's the previous form of NADPH? Just NADP, right?
NADP, yeah.
And in order to add a hydrogen onto it, we need to take that hydrogen from something else, right? And what kind of enzyme deals with removing hydrogens off of stuff and putting it on other things?
Dehydrogenase.
A dehydrogenase. So see how, even if you don't necessarily know the answer, look for things like that. If we think about what the reaction is happening, or we need a hydrogen, what's going to do that? Our dehydrogenase. Same thing if we ever need, like if we're dealing with something's getting phosphorylated or dephosphorylated, make sure that we look at, okay, we're looking for kinases. Okay, which of the following enzymes in the pentose phosphate pathway produces NADPH? This is the exact same question, right? That we just,
Mm-hmm.
yeah, so what's our answer?
Glucose 6-phosphate dehydrogenase.
Yep. Let me make sure real quick. Are we the same answer? 3 questions in a row?
Well,
Oh,
he has all. I would say he has all of the above on that one.
yep, let's take a look. We have glucose 6-phosphate dehydrogenase, we know for sure is an answer choice. Looking through the book, we are here. First production of NADPH, the glucose 6B dehydrogenase. Oxidative decarboxylation. Second, we have our 6-phosphogluconolactone dehydrogenase is the second.
Apologize if you guys hear barking. It's Indy 500 in the background here.
Good. Okay. This is going to be another question. Another question that Kristen, if you could ask him about this, because the glucose 6-phosphate dehydrogenase should be the correct answer, because the phosphopentose isomerase, according to the book and the graphs and everything else, there is not NADPH produced during those steps. And this one, the 6-phosphogluconolactone hydrolase, is not one of our enzymes that we use unless it's an AKA for the dehydrogenase, but I don't believe that's the case. So if you could ask him about this question as well,
I'll ask him.
and
Today.
let us know about that. And hopefully we can get an answer about that. Okay. Which of the following metabolic pathways produces NADPH required for the biosynthesis of certain macromolecules, such as fatty acids?
Pentose phosphate pathway.
Our pentose phosphate pathway. Hooray! One thing that I didn't remember noticing when I was flip through the book real quick, I haven't seen a question on this yet. Maybe we'll run into one in a second. In the final steps of the pentose phosphate pathway, when we get down here, we have a thiamine pyrophosphate, also known as TPP coenzyme. Remember from Sunday, we talked about coenzymes and cofactors. Cofactors are metals. What are coenzymes?
Vitamins.
Vitamins. Thiamine. Thiamine is what type of vitamin?
B.
Vitamin B. B what?
1.
Yep, B1. So he can write here thiamine, thiamine pyrophosphate, just regular thiamine, TPP, or B1 are all appropriate answer choices when it comes to coenzyme. Thiamine pyrophosphate or TPP is the best answer. If it's not there, then thiamine. If neither of those are there, then B1. Watch like the next question be that question. Which of the following metabolic pathways supplies ribose 5-phosphate required for nucleic acid biosynthesis?
The same answer we just had?
Yeah.
Yep, the
Pentose
same
phosphate
answer we just
pathway.
had. Great idea. If you're gonna do Quizlets on this, Elizabeth, are you turning all of them into one mega Quizlet, or are you doing them separately?
All just into one big one.
Good. You can Quizlet has a really cool feature where you can kind of like you can use flashcards and then like swipe if they're correct or not. Like if you get the answer correct or if you know it or not, or you want to continue to review it. Have them all like shuffle and mix so that way you're forcing yourself to jump around between units. That'll help a ton with like active recall stuff. So that's and also if you can, I'd appreciate if you when you finish that, if you could send it to me so that I
Okay.
can keep it. I'm building resources right now for boards type stuff for board prep. Trying to see there's some stuff I have in the works in the background that I'm looking at doing, so be helpful for that.
I made one for the last exam that we had too. They're password protected, but it's always gonna be the same one, and I'll send it to you. So
Yeah, that'd be awesome. Okay, which of the following products derived from D-galactose metabolism enters glycolysis? We talk about galactose entering glycolysis. Which
that was it the UDP glucose?
so think back about it. What do we use? What is the function of the UDP glucose? What is it? What happens when we use UDP glucose?
It breaks it down, and you end up with glucose something. And
let's take it from the top, right? So we have
galactose.
a galactose. The very first step in galactose. I'll write this so it looks prettier. So we start with galactose, and then that gets converted. Let me remember what it gets converted to before I.
Getting ready to say it and I forgot I was muted.
So we have a galactokinase, and we end up with what?
Galactose
6-phosphate.
6-phosphate. 1-phosphate.
Oh shoot.
Let me double check, make sure that I'm correct and. Yeah, we go from galactose to galactose 1-phosphate. Now we use. This is when our UDP glucose comes into play. It interacts with our galactose 1-phosphate and gives us what?
Glucose 1-phosphate and UDP galactose.
Perfect. UDP lactose. And there's a big old long name enzyme in between these two. It's our lactose 1-phosphate uridyl transferase. And then from here, remember our UDP galactose is going to cycle back and become UDP glucose again with another really long-ish sounding name. But overall, the important one to remember that it is an epimerase is what does that job over here. I just deleted it. It's fine. The epimerase gives UDP to UDP glucose. So we're looking at this, right? Our next step, glucose 1-phosphate, is going to go to one more thing before it's able to go into glycolysis. So based off of that right here, we're looking here, our potential answer choices, right? Which of the following, so it's basically asking which product actually physically enters glycolysis? So does UDP galactose enter glycolysis?
No.
Does UDP glucose enter glycolysis?
No.
Does galactose ever become glucose, like plain glucose?
No.
No. So answer choice wise has to be glucose 6-phosphate. A last step here, we have glucose 6-phosphate. And we have a mutase. We have a phosphoglucomutase. Remember, mutases are going to, not isomerases, rearrange stuff. Mutase just moves. It's going to move a functional group. It's going to like move the phosphate off to two different spot. It's going to move those functional groups. Another way, and admittedly quicker way to answer this question, is without doing all of this or thinking about all of this. Which of these 4 answer choices are metabolites of or intermediates of glycolysis? We think back to glycolysis.
I mean, yeah, the glucose 6-phosphate for sure.
Yeah, it's either of these two, because glucose at the very, very beginning, glucose 6-phosphate. But then if we think about it, galactose is never directly converted to glucose, so that gives us our glucose 6-phosphate. Better to know and understand this whole pathway, but again, you can get to the answer just trying to think through the question itself. Which of the following products derived from mannose metabolism directly enters the glycolytic pathway? Have we talked at all about mannose metabolism?
No, but
Super.
thinking about it the way that we did the last one, wouldn't it be mannose 6-phosphate?
Fructose 6.
Directly,
Is it?
glycolytic pathway. Because if you think about it,
Oh,
to
because
enter
it
into the
doesn't
glycolytic
enter.
pathway, yeah, it has to go
Yeah,
into
Okay.
yeah. So we're gonna have the fructose 6-phosphate because that's the only intermediate of glycolysis that's listed here.
Yeah.
So this is the breakdown of mannose, where it's mannose gets acted on by hexokinase to become mannose 6-phosphate, and then we have an isomerase which turns it into fructose 6-phosphate, and that's an intermediate that can dump right into glycolysis. But yeah, that general same logic kind of applies. Yeah, I won't keep beating that horse. Which of the following statements about pentose phosphate pathway is not correct? It involves the conversion of aldopentoses to a ketopentose. It requires the participation of molecular oxygen. Products formed in pentose phosphate pathway can be used for the synthesis of nucleic acids. It is primarily engaged in the formation of NADPH. So right off the bat, products can be used for synthesis of nucleic acids. Is that true or false?
True.
That's very true. It's mainly engaged in the formation of NADPH.
I want to say true. The mainly engaged thing
It
throws
is.
me
It's
off
one
a
of its
little bit.
it's one of its
but
big functions. It kind of has 2 big functions: produce NADPH, and then also produce the pentoses. It involves the conversion of aldopentoses to a ketopentose.
Yes.
That is true, because remember, what is it?
Let's see.
What aldopentose does it convert? Or what are the pentoses that it talks about? We have the aldopentose is the ribose 5. And the ketopentose is ribulose, which if I'm not mistaken, I think that question might actually be worded a little bit wrong. Because I think it technically should be because ribulose goes to ribose. Ribose 5. Phosphate goes to ribose 5. Phosphate. And ribose is an aldopentose. And ribulose. Right? That's what we had said earlier.
Yeah.
You double check with the almighty Google. Ribulose, aldehyde, or ketone. Yeah. This should read ketopentose to aldopentose. Christine, do you want to ask him about that as well?
Yes, I will. My mute button's being sticky.
Yeah. Double check with him on that one. I think that's just misworded. Answer is this. It requires the participation of molecular oxygen. So that's another one where if you know it well enough, you can want to say something better than fight for your answer choice, but
Yeah.
defend your answer selection if you had put the first one as not correct. Which of the following statements best describes one of the major contributions of the pentose phosphate pathway? Produces sterols. It does not produce ribose 5-phosphate. It produces NADPH. It forms glucose.
NADPH.
NADPH. Sterols, you'll talk about those next trimester. And when you talk about like steroid production and that sort of stuff. It does not produce ribose. It does produce ribose 5-phosphate, and it does not form glucose. That is not its job. Last question. Which of the following enzymes does not participate in the pentose phosphate pathway?
All of the above.
I'll say all of the above. None of those do that.
All of these guys are our glycolysis going into the Krebs cycle. Sweet. How do we feel overall now about our sugars, our different pathways, and the pentose phosphate pathway?
Not too horrible.
Better than I did, for sure.
The pentose phosphate pathway, again, like I said, I don't love the charts and stuff that he has going over it. I feel like there's just like a lot that he has in the book. It can be broken down a little bit simpler. I would highly recommend. I'll see if I can find that because I swear I had one saved somewhere of a little bit more clear pentose phosphate pathway. But overall, the information that we've covered and that we've gone over definitely, I think, will cover us pretty well for anything that he'll ask in the exam.
Yeah. We had our review session with him yesterday. Went just over an hour and a half. A little lengthy, but he went over pentose pretty well. But I'm like, he can get on his soapboxes and like beat it till the horse is dead kind of deal.
Yep.
I'm like, but he also had a couple phone calls in the middle of our review session, so we had to pause. So But at least he was in a decent mood. Like, and when he's in a good mood to do private sessions, you can always tell he's a lot more laid back and he's not so stiff, so to speak.
Yeah.
That is probably, besides your sessions, the one thing that has been my saving grace this term. So
Good.
No, I told somebody today, I was like, I owe